All right, welcome back, everybody. For our next panel, we're going to talk about the real challenges around not only securing all of this cloud to sensor connectivity and securing the edge AI that is captured, but it's really about understanding the growing threats around cybersecurity and what we can do as a community to help our developers make more and more system-level design choices that can help them weather this emerging security storm. So for the next panel, we have a group of industry experts joining on stage. Also is Indy from our Meta keynote, and we're going to expand and take a click down into the growing security storm here in our resilient security panel. So please give everybody a warm welcome to our security panel. Welcome. I'm going to just do a quick introduction here. So first, to my left, joining me from AMI is Stefano Righi. Welcome. Thanks for joining us.
Thank you.
Joining us from Intel, we have Jean Guillory. Welcome.
Thanks.
Joining us from Lattice, our Chief Strategy and Security Lead, Mr. Eric Syverson. Thank you for joining us. Joining us again, Indy, thank you again for that wonderful keynote. Joining us from Meta, Indy Banerjee, thank you for joining us. And then last but not least, co-founder and CTO of SecureIC, Dr. Sylvain Guillet.
My pleasure to be here.
Thank you. I hope I got all that right. I apologize if I misspoke anyone's names. So we talked at the developers conference around the opportunities around edge AI. There's clearly all kinds of new applications that can be done at the edge. We talked about the opportunity in the industrial factory around creating new use cases around industrial automation that requires taking data and moving it from the sensor into the cloud. But I think as we go and talk to every single industrial vertical, every market vertical, including industrial, and all the other verticals that are trying to leverage some of the same technology advancements, cybersecurity is clearly on everybody's mind. So building on what Indy presented earlier, Eric, could you give us a little bit of an overview of the growing security storm, as you like to say, and give us just help us navigate, what's going on and what are the different topics that we can cover today to kind of address some of the challenges that the developers are going to be facing?
Yeah, sure, Matt. So I think, to use a borrowed phrase, may you live in interesting times. And we're kind of going to go through a period of profound change, if you think about it. And our panel at the beginning on AI, the presentation on that, the discussion on cloud, I'm going to bring you around to a concept by Ray Kurzweil called the singularity. It's the first time in humanity where machines and humans are now starting to coexist to make decisions. And the impact of that on security is going to be and is profound right now. And so what you're seeing, and I liken it to a storm, as Matt said, is that we're moving out of an old paradigm. I like to call it a castle model. If you think about the enterprise a long time ago, it was guns, guards, and gates for a human to get into a data center, to get inside and be able to wreak any havoc, right? It was very contained and very controlled. And now you have literally rolling data centers. I like to look at Tesla as a great example. That EV has an AI engine with more capability than an F-35 fighter. So when you think about it, that car is running around generating gigabytes of data per minute, just like what we heard from Amit this morning. And all that information is now being used to take a human out of the loop. In the guns, guards, and gates model, you're really looking at humans allowing people into the castle. Now we have basically a rolling, and it's not a castle, this is the problem, data center that's completely automated with no humans in the loop. It'll drive you around. And the profound security impacts from this are huge. So back to the storm idea, What's really happening is you have all of these devices no longer in a protected bubble, but available to everyone. Any miscreant on the planet can go buy a Tesla vehicle, break into it and figure out how it now operates, and now take advantage of that to do some type of an exploit. So you'll see this in the NVD, the National Vulnerabilities Database, where firmware vulnerabilities are exponentially growing every year. And there's an equivalent amount of exploits, just like my friend Indy was telling you about on the gray market, to go after those vulnerabilities. Yep. So you have an exponential growing attack surface. And now, and we just heard a minute ago that factories are going to now deploy 5G internally. It's this massive connectivity with high bandwidth, so you now have low-cost devices that can magically penetrate the castle from outside and get into these networks with high-value data and high-value systems. So exponential attack surface growth, and now exponential vectors to come in and attack it. And then here's the last part of this component. You have AI that's now going to start to compete with humans in perfection. So imagine all that, and now AI bots coming in to make that attack. And so that's the storm that I'm kind of trying to show that's happening. And then to borrow a Steve Jobs phrase, and one more thing, if that's not enough for you, we're about to change the foundation of the security algorithms with a post-quantum algorithm set. So everything that we've already deployed and put in place is now in jeopardy, and we have to go and completely change all that in the middle of all of this chaos of an exponential attack surface growth, an exponential vector in to hit it, and then a brain power that could exceed what we have as humans to go do those exploits. So that's the perfect storm, Matt.
You're not making me feel very good. That's why we're here. So let's just kind of start with, okay, how do we go take that and actually protect all of the devices and all that data that you just talked about? And maybe, John, why don't you tell us, Intel is a wonderful partner in securing the data center. We've worked together in a number of different projects across different hyperscale and OEM server platforms. What are you ship in more data centers than any other semiconductor provider. Tell us what Intel's priorities are on battling the storm.
I mean, there's, like Eric's saying, there's so many things to worry about, right? So we have, we have all sorts of different, technologies to worry about different things, from, protecting your data when you're in the cloud to protecting, against, some nation state attacks, right, on the platform, protecting the hardware level and the firmware level. So there's all sorts of different things that we use. I know, we like to work on Lattice for our platform Root of Trust solutions, where we try to protect the firmware that's on the data center platforms to kind of prevent from those low level attacks that are kind of becoming more and more prevalent, and there's more and more opportunities that are happening there. So that's one of the things that we focus on with Lattice.
Oh, that's wonderful to know. Thank you for the partnership, Stefano. When I think firmware, I think you. Like literally in my phone, when I type firmware, your name comes up. So tell us about, in the spirit of the hardware and the storm and the work that we're doing together to activate those protective measures. Tell us what AMI is doing and how can the developer community help?
Sure. So as Eric was indicating, this storm is huge, and we can see that the number of attacks that are happening not only from nation states but also from groups that perform attack for monetary purposes to get ransom are always increasing. For example, I was reading that this year we are out for a double of cases of cyber attacks in the European Union. And what we are doing in order to counteract this big challenge is to really, as John was saying, protect the platform, because we believe that the paradigm of zero trust that we were hearing about this morning is possible only if you protect from the platform itself. Because if you have an attack on firmware, and with the standardization of firmware, we see that these attacks are always rising. These attacks will not be detected for a long period of time because they are under the operating system. So every virus protection, every software that protect all our digital assets will be completely undetected. So what we do, we have augmented our product base, not only with BIOS and BMC firmware, but also with a platform root of trust solution on which we work with your FPGA, with Mac and X, and the new generation that are coming out, in order to make sure that your machine will always boot with original firmware, not being attacked, not being and even if a rogue agent is able to inject something into the platform, into the firmware platform, with the recovery capability, we restore the original state before booting to the operating system, so that we can guarantee that every time that the operating system is starting into your machine, is starting from a secure base. Besides that, we leverage the platform root of trust also to perform remote attestation and other services for data center, but not only that, allow operators to monitor that your infrastructure is constantly secure.
And those individual components, are those done broad-based for just every product, or are those very specific implementations that happen at every customer?
So we have a base that is, let me say, common for all the implementation. But at the end, because all hardware platforms are really different one from the other, we always need customization, and we offer services in order to adapt our code base to the various hardware implementation that our customer, so our common customer.
Flexibility is very important.
Absolutely.
All right, that's very, very good to know. You know, as I think about the storm, you know, one of the elements of this is, you know, quantum computing. When I talk to my team, and Mamta on my team, you know, is very much into quantum computing, and she tells me about what quantum computers are going to be able to do to what we understand as the current state of whether it's the internet or just the way that we do security algorithms today. Many of these things are going to change what feels like overnight. And you know, Sylvain, maybe you could talk a little bit about what is coming from the storm that is based on just the capability of quantum computers, and how do we protect against that upcoming storm?
Yeah, clearly this is yet another storm, so there are a lot of challenges. Everybody has heard about the quantum computer, so in general, it's really great news. Quantum computers will bring a lot of benefit to our society. It will even help AI, and so solve very difficult problems. In terms of cybersecurity, quantum computers actually will also break today's algorithms. Okay, the very foundation of our security, for instance, attesting of a digital signature, checking firmware integrity and authenticity, will no longer work with today's algorithms. That's for sure. And so there is definitely a turn to make and actually to revisit entirely the cryptographic algorithms and to switch to so-called post-quantum cryptographic algorithms. Those algorithms are running on electronics. It can fit into FPGAs typically. Okay, so my company is showcasing a demo just downstairs about some PQC implemented in Mac NX FPGA. Okay, so it's something that can be done today, but the real challenge now is to switch from classical to PQC, and this is a long way. You know why? Because actually it goes from the silicon for the secure boot all the way to the cloud. All the algorithms need to transition to PQC, so it's a real challenge. And actually, FPGAs are really a blessing, so to say, because you can implement them like that, retrofit, and all of a sudden your chain of trust gets quantum secure.
That's first of all. So just so I understand that maybe I'll summarize this in my own words for the audience. So what I hear you saying is the processing capability of quantum computers is going to make it easier for malicious actors to break today's algorithms faster. Is that the way to think about it? But FPGAs, because of their architecture, have an innate ability to be able to be flexible enough to then have algorithms put into them that are then quantum safe and then can maintain that protection. Is that how I understand that?
That's exactly what's happening. And so the concept that you define is crypto-agility, meaning the ability to switch, to transition to one algorithm to the other, which is enabled by the flexibility inside of the FPGA.
Okay, and so I've heard also, and maybe Indy, maybe you could just talk about this a little bit too, because there's a lot of regulation also being discussed around what nation states and what critical infrastructure, including data centers and hyperscalers, have to abide by with some of the new regulation that's coming. I've heard quantum computing safe algorithms are part of that. How do we think about some of the upcoming regulation, and how does that drive your forward roadmap on the things that you need to protect for in the future, and maybe touch on some of the things maybe Sylvain talked about with quantum computing?
So what this makes me think about is so from the customer perspective, we have to plan out our our hardware and our silicon roadmaps several years, 3-5 years in the future. And for that, we need clarity around which algorithms, which protocols to support in our security stack. Now, that becomes very difficult when the space of post-quantum algorithms is still evolving. There's still a lot of ongoing research. The NIST standardization process is nearing its conclusion. It has come up with certain recommendations, but they're still undergoing a lot of change. So from the customer perspective, there's a lack of clarity, and this contributes to the storm, is around, hey, what security protocols should we pick for the next generation of hardware and for the next generation of platform root of trust solutions? And I think, Sylvain, you will agree that this is, as this space evolves, crypto-agility is going to be a very important property, because we're going to make some decisions today based on incomplete information, and understandably, some of those decisions are going to turn out to be wrong. Now, it can be on what algorithms we pick, or it can be around what key sizes and signature sizes we configure. And I think FPGAs play a big part there, because it will allow us the flexibility to be able to configure those post-deployment.
That's great. And it's interesting is when you talk to other markets, not just the data center market, which many of you are experts of, the same challenges are being placed on firmware security. The same rules to secure systems are being placed. I feel like the data center is the tip of the spear, but it's now quickly waterfalling down to other markets as well. And there's a lot of security solutions out there. There's TPMs, there's BMCs, there's root of trust devices, including our portfolio. Eric, help me understand like the difference between if I'm a developer now that is now all of a sudden thrown into a project at an industrial customer that has now a requirement for cybersecurity, and I've got this menu of existing current devices. Walk me through the challenges of picking what's on the menu today versus the storm that's being addressed by the data center first.
Yeah, that's a good question, Matt. So I think what you want to understand, and I didn't give you the whole, I gave you the fear, the front end, the terror of the storm. And the question that ties back to this is, what's the answer? How do you shelter from this thing? And I say it's the battle cry of man and machine. And if you look at human evolution, and now we're going to add machines to our evolution, it's resilience, right? So at the end of the day, humans have survived. We are, they're not Neanderthals running around, it's Homo sapiens, because we were the most resilient breed. And so what's going to happen in the future, and the way you're going to solve a lot of these problems, Matt, is to be able to build cyber resilient systems. So this is more the machine side of things. At this point, humans are going to be driving that development. In time, you'll see machines cross over and help with that, and hopefully not in a malicious way. And that'll be up to us collectively how we solve that. But what you want, when you look at like a TPM or a BMC, that is a legacy castle model solution. It will go the way of the dinosaurs when it's all said and done. And what you really want is you want to see systems at the lowest component level to be resilient on their own. This ability to do what we call protection, detection, and recovery in real time on any system at the lowest level. And in the data center, PFR is kind of mandating that. It's the beginning of that evolution. But as we move down and you're riding in your Tesla, and I don't know if it was, I think it was Denny that brought this up, that it terrified him about that Tesla having that accident, and he didn't like that kind of AI. This resilience is what's going to ultimately stop those type of problems. So I think if I was advising a developer today, the key is you need to start looking into how do I build a natively electronic, automatic, resilient system. And again, I'll put a shameless plug in for FPGAs. They're really good for this technology, and I think everyone on the panel here will agree with me on that.
So let me quickly differ a little bit with Eric here. Eric, I'm just like everyone else, I'm also freaked out by AI, by ChatGPT, and what it can do. But in this specific instance, I think by focusing on the understandable doomsday narrative of AI, we might be overlooking some more basic forces that lead to the storm, such as the availability of hacking tools and training and technology to a large part of the world that did not have access to this technology before, right? So if you compare the threat landscape to what it was 10 years back, I think we will find that the barrier to access, that someone needs, the tools, the training that someone needs to develop an exploitable vulnerability and then go ahead and deploy it against an enterprise has come down by a lot, and a lot more people in remote parts of the world are now able to get access to that technology. And I think in the short term, at least in the short term, that might play a much bigger role in the onslaught of security incidents that companies like Google and Microsoft and Meta will have to deal with in the future.
Yeah, and I totally agree with you on that too. I think, like I said, it's going to be an evolution, and part of the storm, and if it's okay with you, I'm going to steal this now from you in my next presentation, is definitely the short-term impact of more miscreants being weaponized, if you will.
So what I heard in that, along with don't always fear the AI, there's other ways to solve it.
Oh, yeah.
Is really around lowest level platform firmware. And you talked about PFR and protection, platform firmware resiliency. Jean, maybe talk a little bit about, as PFR gets adopted in the data center, what are some of the basic functions that you can expect being rolled out across data center customers? And then how could we expect some of those things to maybe carry forward into other markets using that tip of the spear analogy with you guys leading and those challenges and solving those challenges to other markets down the road?
Yeah, I mean, well, definitely, I think kind of, foundational of PFR is the resiliency factor, like Eric mentioned. It's very, it's very important. And so I think that's I think something people are thinking about already. But now as we, go forward, when we have attestation, right, where we can, kind of use a platform root of trust to communicate with other devices in the platform, I think this is going to be something adopted more and more. Some of these standards and other industries too, because it's something that I think is useful. Everywhere. So I think that's going to be something that to look forward to, and for other devices to consider that. And I do think that like you said, we might be worried about it in data center, but you have to worry about it everywhere. The attackers are getting more and more creative, right? So if developers, if you can think of a way that that your system could be attacked, somebody else is going to figure it out too. So that's something that is there's going to be more and more of that, I think, everywhere.
Well, thanks for that. Thanks for that perspective. And Stefano, can you maybe just talk a little bit about the differences that you're seeing in how the adoption of security is shaping some of the engagements you have in the market?
Sure. So security is an aspect that, yes, has started with data center, but is coming to affect every aspect of our life. Not only systems that are going to be included in data center, but any device that these systems are becoming more and more complex. So it is really a matrix approach that is going to happen, because with devices that are becoming more and more complex, every subsystem that is present into the device will need to be independently protected in order to be able to be combined with the other subsystems that are present into the platform, in order to create a complete system that is secure, with a platform of trust that can attest to the rest of the world that the entire system is secure. The other side of the matrix is that, every sort of devices is going to be protected, not only server in data center, but also notebook, also desktop, also every sort of computing device will need, as long as it is connected, will need to be protected by possible attack of rogue agents. And this protection is something that need to evolve, and what better than FPGA can allow for updating the algorithm, like Sylvan was talking about. We will need a more robust algorithm, and this means that security is in constant evolution, and we will need to provide updates, and these will also be required, by the way, by the regulation that we were talking before, because regulation like the CRA that is coming up in Europe will demand that manufacturer will continue to support security on the devices for all the year for which the system will be maintained. And this will be applicable to every class of system. Also the notebook that we bring with us every day, so on and so forth.
Yeah, so on the regulation thing, I think we talked about it in the context of quantum computing changing everything. Yeah. But in terms of just mandates coming down from different nation states, like Eric, maybe talk a little bit about what are some of the new regulations that are coming, and what are some timelines or rough dates that you could provide to just inspire some motivation for the development community?
Yeah, so I think, I'm just going to pick up where Stefano left off, just for everyone's knowledge, because we're also into this, but CRA stands for Cyber Resilience Act. And so this is where, again, back to the resiliency point, this will be a European Union effort. It's legislation that's predicted to come out in the 2024-2025 timeframe. And if you're familiar with devices with the little CE logo on them, that's all from the European Union to be able to sell your product there. And so what they're going to mandate is a set of true resiliency requirements on products now to be sold into the European Union. And so on one hand, no one likes compliance and the risks of not doing that, because there'll be fines and consequences if you don't do it. But on the positive side, this is really going to give more of a framework of how to make a resilient electronic product. So I think in a lot of ways what the European Union is doing with this act is going to be very good for all of us. So you're going to see that happen. You are also seeing, like we've all talked about here, the post-quantum algorithms that will be ratified by NIST, and that will probably happen in this similar time frame. And then that's going to have a disruption to all of these legacy PKI algorithms being changed out. So you're going to see a lot of that happen. And then you're going to see industry bodies like the Trusted Computing Group. This is the organization that brought you the TPM, Trusted Platform Module. They've already put out a specification called Cyber Resilient Modules and Building Blocks. That specification was dropped summer before last. And you'll probably start to see other work groups within TCG adopt that, like the industrial work group, the comms work group, and even some of the data center and compute groups to start to put that high-level set of specifications now into protection profile-like ways of implementing in specific vertical markets. So there's going to be a lot of guidance coming to the world to help us make better systems. So that's the good side of it. The hard part, and back to my storm analogy, is there's a lot of churn between now and when all of that gets finalized. And so if you are trying to build a piece of silicon, such as an ASIC, you can't really bake this stuff in because there's a little bit of movement. You don't know where it's going to land. And again, this is where FPGAs, programmable hardware, gives you an advantage.
Just expanding on the algorithms a bit, Sylvan, could you maybe just talk a little bit? I know, that, first of all, just for the viewers out there, we have a lot more detail online in our portal from our contributors, from Secure IC, from AMI, from Intel, to go through block diagrams and ways to implement this stuff. So please, you don't have to take notes on this. But maybe, Sylvan, explain some of the post-quantum algorithms that your company is investing in and partnering with Lattice that you believe can future-proof or create a quantum-safe computing platform for some of the customers or partners that might be listening in.
Sure, Matt. Actually, there are several uses of PQC. The first use is foundational to the security of devices and actually resides in the secure boot. So secure boot is about checking the signature of the firmware you execute before you execute it, okay? And then it's a chain of boot. Then this firmware then will be checking the integrity and the authenticity of the next firmware, and then you can extend the scope of the trust. Those algorithms actually are mostly ruled by hash-based post-quantum cryptography, leveraging SHA-2 or SHA-3. Some of the algorithms are actually already hardened in some of the Lattice products. Okay, so implementing them can be as easy as implementing the control of the algorithm, but the data path of it, the data processing of it, is already inside of the FPGA. Okay, then comes other algorithms, typically for securing data in a transfer. Typically, you want to secure your TLS, your IPsec. Okay, in this case, actually, there is a requirement for even stronger algorithms that are called lattice based out of Euclidean lattices.
Not our company.
It happens to be funny. But such algorithms that are indeed in the final stage of being drafted and standardized by NIST, are named by Kyber and Dilithium, and those actually require a completely different computation strategy based out of very huge vector computation. A lattice is basically a multi-dimensional set of numbers, okay? And so we've been developing such algorithms to fit inside of the FPGA matrix. And let me just highlight another aspect about crypto-agility. We mentioned crypto-agility because those algorithms are still in the process of being standardized. So some tweaks can happen, okay? So we need to be aware of that to be future-proof, okay? That's one aspect. But another aspect is the PPA, power, performance area, okay? So for some applications, typically secure boot, you don't want to wait, seconds to boot. That's just not possible, okay? So you want it fast. For other applications, you want it low power, you see? So there are different flavors, and not to mention about security. Security resides in the key size, but also in the effort put into the implementation to protect it against timing attacks, power attacks, EM attacks. So all those, let's say, implementation tricks that will make the algorithms more or less resistant to attackers. And so to conclude on my answer, we've been at SecureIC doing a partnership a long time with Lattice, actually, to develop this portfolio of different algorithms that will fit into each part of Lattice portfolio.
Oh, thank you, Sylvain. And first of all, thank you for the partnership. Just from my understanding, I want to just repeat what I heard, which is within our Lattice FPGAs, we have SHA-2 and SHA-3 capability, which you describe as a platform to then be able to run post-quantum safe algorithms on top of. Is that the way I should think about that?
Exactly. So today, leveraging the hardened SHA-2, it is possible to do a post-quantum secure boot, and this is already feasible with today Lattice technology.
Oh, that's excellent. And by the way, just for the viewers that are trying to connect the dots, earlier in our developers conference, we showed a demo. Deepak demonstrated a demo of the latency of a Lattice FPGA starting up versus some of the other devices in the market starting up. And really the point there is that in the time it takes to boot up a system or flash that FPGA, malicious actors can insert, firmware or not the correct firmware and things like that. So it was really amazing to see the innovation in the hardware being able to keep up with the attacks as well. Eric, just kind of going back to the priorities within Lattice around our roadmap, around the kinds of things you see us investing in around security, so that as our developers are out there, and it sounds like there's a lot of different options and a lot of uncertainty of where things are going to go. What is the scope in the landscape of the Lattice security strategy? What can you expect, to deliver to the market?
Yeah, so I think one of the things that Lattice has done a very good job with is to have a broad portfolio of FPGAs, which have lots of security features, which are very useful. But then we also have very specialized portfolio. We call them our root of trust products. And those products have evolved quite nice over the years. And they really give a very strong foundation to build all of these security solutions on top of. And what I mean by that is you can securely boot the part. It has integrated flash, dual boot integrated flash at that, and that flash can be locked off and protected. With many of our competitors, they have to go external in order to get non-volatile memory for their bit stream to actually configure. And that's a denial of service attack right there. And so with our parts, it's all integrated. And not only can you guarantee that the part will boot and boot properly, but it can self-supervise its own update securely in a way that it cannot be compromised easily or to deny service. So we have really foundational secure booting. We have very strong foundations for unique attestability. We have secure, immutable, unique IDs. Pardon me for going back to the human analogy, but trust is really not an electronic term. It's a human term. And again, through evolution, it's your mark, your signature, and then eventually your fingerprint, now ultimately your DNA, gives uniqueness. So we put electronically the same equivalent into our rooted trust parts. So you get great secure boot, you have unique attestability features so that you know the device that you're dealing with. And then further, Matt, what we've built with our solution stacks that were shown off earlier this morning, we have a complete cyber resilience stack we call Sentry that makes it easy for you to take that root of trust and now build a very resilient system, either on that device itself or other devices on the board. And then last but not least, to Indy's point a minute ago, the supply chain of today is very brittle, very chaotic, and very fractured around the world. It's one of the easiest places to come in and inject an attack at low cost onto any device. And so we also have a service we call Supply Guard that makes it very easy for you to have a very resilient and strong solution at low cost as you go through the supply chain.
That's one thing that we didn't really talk about yet, but I saw that on, Indy, your presentation, and I've certainly seen this from presentations from Intel and from AMI, but the supply chain element to security. So I guess when I buy something at the store and I get it home, I expect it to be safe and secure until I do something stupid with it, right? And then it's not secure. Yeah. So help me understand what you mean by supply chain security, and what are the risks there of, can you explain that a little bit further, Eric or Indy?
Sure. Yeah. The way I understand supply chain security really comes down to sort of three levels of security. The first is really, the first objective is to get visibility into the supply chain and really understand where each component on the BOM is originating from in terms of which supplier, which assembly or testing plant it's originating from. Second is being able to guarantee the integrity of the component, both the hardware and the firmware, along each node. When it's shipped across the ocean, when it lands at a port, when it's stored in a warehouse, being able to guarantee that only authorized personnel have the ability to access them, and also being able to detect any tampering both to the packages as well as to the hardware and firmware on the device. So that's two aspects. The third aspect I think about in supply chain security is once the part is deployed in a data center or in an enterprise IT environment, being able to dynamically attest when the part comes up that this is a valid Lattice part which is provisioned with a certificate from Lattice that we trust. So those are sort of the solutions, the countermeasures I think about in terms of when I talk about supply chain. Now, quickly talking about the threats, the threats are, as you would imagine, there are many reports of cyber crime groups as well as nation-state actors with three-letter acronyms. What they do is intercepting, say, Cisco switches, or intercepting, HVAC control systems or payment systems en route to their deployment location, and then implanting parts into the board which are not actually part of the BOM. Implanting parts which can run a remote access Trojan, some software that is able to receive commands over the network and then execute them surreptitiously without the knowledge of the end customer.
So if I get this right, essentially, you have to think about the supply chain not only in terms of the parts and how the parts are put on the board, but then also making sure that anything that happens with those systems in the field, those devices can trust the firmware that's actually ultimately going to be updating them. And I think, Eric, what we do in that instance is, when I say we, I mean Lattice, with SupplyGuard, is we create the ability to manage those keys in a way that not only do we trust the keys that are, burned into the devices at production, but then also the way that we deploy how to unlock those devices is also managed separately through a direct path to the customers using those devices, right? Could you maybe talk a little bit more about SupplyGuard?
Yeah,
I might
sure.
not paraphrase that, right?
Yeah, no, you're on the right track, Matt. I want to pick on a point Indy made earlier today in his talk, which was excellent, by the way. Zero trust. I mean, ultimately, you want to have zero trust in the supply chain. Whatever system you're going to build needs to have zero trust. Whenever you rely on elements within the supply chain for security, there are two problems that will occur. One, you're going to pay for that. And then second, if you're sharing anything that is related to your security with these elements in the supply chain that probably are not worthy of your trust, you're opening yourself up to exploit. There's a really good exploit, I won't go into the details, but look into, the name is called Zombie Zero. Go do the research. This is where a nation state paid hackers and a contract manufacturer to work together to basically put in a backdoor and hand scanners to get inside a firewall. And the reason it occurred is because the hand scanner makers trusted the CM and gave them access to the secrets to put into the device. So ultimately, and this is where SupplyGuard kicks in, we want to build an environment where even our customers don't have to trust Lattice. The keys to the kingdom, if you will, are managed purely by the customer and never shared with anyone else in the supply chain, including Lattice. And so when we built SupplyGuard, we built with that in mind. And to your point on the key management, Matt, we start with a Lattice key, but then when our customer takes over the product, and for that, because we have flash on board and can lock it, it stays in a locked state, but now the customer takes over the product with his keys and IP, and ours are removed. It's always forward security with no pathway back, and our customers never have to share keys or their intellectual property with anyone in the supply chain. Total zero trust solution.
That's fantastic. Well, I again want to reiterate to our audience, thank you again for listening. But again, I want to make sure go to latticesemi.com and you can see examples not only of SupplyGuard, of our portfolio that has root of trust embedded into the roadmap, and along with wonderful presentations and demonstrations from our partners that have joined us on the panel today to talk about how the devices and the work that you're going to do in future customer implementations can be secure and meet the standards of the regulations that are coming. So I certainly learned a lot today. Thank you very much for your time, not only in the keynotes, in the participation in the panel, but also in the work that you do to secure us and our customers. Thank you very much for your participation today. Audience, please give a round of applause to our panelists today. Thank you very much.
Thank you.
Thank you.